Hey full stack devs! Let's continue our video series on backend concepts. The world of backend development is a constant puzzle of interconnected ideas, and a strong grasp of them is what makes you a true pro. From synchronous and asynchronous to stateless and stateful, we're diving back in to untangle 15 more concepts that might be tripping you up. Let's get right into it and level up your knowledge, part 2. First up, synchronous versus asynchronous operations. A synchronous operation is like a single-lane road. Each task must be completed before the next one can begin. Your code waits for one function to finish, then moves to the next. This can be easy to reason about, but can cause your application to freeze if a task is slow. An asynchronous operation is like a multi-lane highway. Your code sends off a task and continues running other code without waiting for a response. When the first task is complete, it triggers a callback. This is essential for non-blocking I/O operations and keeping your app responsive. Let's dive into the key differences between stateless and stateful server architectures in full-stack development. A stateless server handles each request independently, without retaining any information about previous interactions with a client, ensuring efficient scalability. Imagine a cashier who forgets your order from yesterday. Every request must include all necessary data, like a fresh order, which suits high-traffic systems like REST APIs. In contrast, a stateful server maintains the client's state across multiple requests, enabling seamless data continuity between interactions. Picture a conversation with a cashier who remembers your preferences. This simplifies apps like chat systems but complicates scaling due to session persistence requirements. Let's explore API protocols by comparing REST and SOAP, two foundational approaches in full-stack development. REST, or Representational State Transfer, is a flexible, lightweight architectural style that leverages standard ATP methods like get, post, put, and delete for seamless client-server communication. As a stateless protocol, REST is easy to implement, widely adopted in modern web apps, and excels in delivering simple JSON responses for scalability. SOAP, or Simple Object Access Protocol, is a formal, XML-based protocol with strict standards, designed for robust and secure data exchange. SOAP enforces a rigid message structure and a strict contract, making it ideal for secure transactions like banking, but complex to implement and heavier on resources. A critical performance factor in full-stack development is understanding blocking versus non-blocking I/O operations. Blocking I/O forces a process to wait until the input-output operation, like reading a file or querying a database, fully completes before moving forward. This sequential approach, akin to waiting in line at the DMV, can bottleneck resources, slowing down applications under heavy load. Non-blocking I/O allows a process to continue executing other tasks, while the I/O operation runs in the background, like getting a buzzer at a restaurant. This asynchronous approach maximizes efficiency, enabling servers to handle thousands of concurrent connections, vital for high-performance apps like Node.js servers. In user authentication, choosing between session-based and token-based approaches can significantly impact your application's scalability and security. Session-based authentication stores user state on the server, creating a session ID upon login, which is typically stored in a client-side cookie for subsequent requests. This stateful approach requires the server to maintain session data, which can complicate scaling across distributed systems like microservices. Token-based authentication, such as JSON Web Tokens, JWT, is stateless, embedding user information in a secure token sent to the client upon login. The client includes this token in every request, allowing the server to validate it without storing session data, making it highly scalable for modern applications. In full-stack development, choosing between an ORM and a SQL query builder shapes how efficiently you interact with databases. An ORM, or Object Relational Mapper, enables developers to work with databases using object-oriented programming, abstracting complex SQL queries. With tools like SQL2Me or Hibernate, you write classes and objects that translate into SQL, speeding up development, but sometimes generating inefficient queries like N01 issues. A SQL query builder, such as Next.js or Prisma's Query Mode, offers a fluent API to construct precise, optimized SQL queries programmatically. This approach provides greater control and avoids raw SQL vulnerabilities, though it demands more manual effort than an ORM's automation. In modern web development, choosing between server-side rendering, SSRs, and client-side rendering, CSR, impacts performance, SAO, and user experience. With SSR, the server generates and sends a fully rendered HTML page to the browser, ensuring fast initial load times and excellent SEO performance. Frameworks like Next.js leverage SSR for content-heavy sites, such as blogs or e-commerce platforms, delivering pre-rendered pages instantly. CSR sends a minimal HTML file with a JavaScript bundle, allowing the browser to dynamically build the page by executing the code. React-based apps often use CSR for highly interactive experiences, but initial load times and SEO can suffer without additional optimizations like hydration. Organizing your codebase is a critical decision in full-stack development. Monorepo versus multi-repo. A monorepo stores all code for multiple projects in a single repository, as used by companies like Google and Facebook for streamlined code sharing. This approach simplifies dependency management and cross-project collaboration, but can overwhelm small teams with its complexity. A multi-repo uses separate repositories for each project, offering isolation and focused workflows for individual teams. While intuitive, multi-repos can lead to code duplication and challenges in managing dependencies across projects. For efficient inter-service communication in distributed systems, developers choose between message queues and pub-sub models. A message queue operates on a point-to-point model, where messages are sent to a queue and processed by a single consumer, like a task list for one worker. Once consumed, the message is removed, making it ideal for workflows like order processing that require exactly once delivery, as seen in RabbitMQ or AWS SQs. Pub-sub, or publish-subscribe, allows a publisher to broadcast messages to multiple subscribers simultaneously, supporting event-driven architectures. This model excels in scenarios like real-time notifications, where multiple services, such as logging or analytics, need to react to the same event, as with Kafka or Redis pub-sub. In DevOps, containerization versus virtualization is a key decision for deploying applications efficiently and consistently. Virtualization creates full virtual machines, each with its own operating system, running on a hypervisor like VMware or VirtualBox. This provides strong isolation for running diverse OS environments, but introduces significant resource overhead due to duplicated OS instances. Containerization, using tools like Docker or Kubernetes, packages applications with their dependencies into lightweight containers that share the host OS kernel. This ensures portability and efficiency, enabling consistent app execution across development, testing, and production environments. In web security, CORS and CIRF address distinct concerns, but are often confused in full-stack development. CORS, or Cross-Origin Resource Sharing, is a browser mechanism that restricts websites from making requests to different domains for security. Servers use CORS headers to explicitly allow or deny cross-origin requests, crucial for modern APIs interacting with multiple domains, like in microservices. CRCRF, or Cross-Site Request Forgery, involves malicious websites tricking a user's browser into sending unauthorized requests to a trusted site. TSARF tokens validate request origins, preventing attacks where servers execute unintended actions, such as unauthorized bank transfers. For real-time data in full-stack applications, developers choose between WebSockets and HTTP polling to deliver dynamic updates. HTTP polling involves clients repeatedly sending requests to the server to check for new data, often resulting in inefficient network usage. This approach, like a child asking, "Are we there yet?" on a road trip, wastes resources when most responses return no new information. WebSockets establish a persistent bidirectional connection, allowing the server to push data to the client instantly when updates occur. This is ideal for real-time applications like chat systems or live dashboards, as seen in tools like Socket, I/O or WebSocket APIs. In modern DevOps, infrastructure as code (IAC) versus configuration management defines how you manage infrastructure and applications efficiently. IAC involves defining and provisioning infrastructure, servers, networks, databases, using code, enabling automated, repeatable setups. Tools like Terraform or AWS CloudFormation allow developers to script entire cloud environments, ensuring consistency across deployments. Configuration management focuses on configuring and maintaining the state of applications and servers after provisioning, such as installing software or setting up files. Tools like Ansible or Chef automate these tasks, ensuring servers are correctly configured for specific workloads, like web or database servers. In cloud networking, understanding virtual private cloud (VPC) versus subnet is crucial for secure and scalable infrastructure design. A VPC is a logically isolated virtual network within a public cloud, like AWS or Google Cloud, giving you full control over IP ranges and security settings. Think of a VPC as your private, secure plot of land in the cloud, tailored for your applications and resources. A subnet is a smaller segment within a VPC, dividing the IP address range into manageable, isolated sections for specific purposes. Public subnets host internet-accessible resources, like web servers, while private subnets protect sensitive resources, like databases, from external access. In data engineering, ETL versus ELT represents two distinct approaches to building efficient data pipelines for analytics and processing. ETL, or extract, transform, load, is the traditional method where data is extracted from sources, transformed in a staging area, and then loaded into a destination like a data warehouse. Used in tools like Informatica or Talend, ETL ensures data is cleaned and structured before storage, making it ideal for structured datasets and legacy systems. ELT, or extract, load, transform, loads raw data directly into a data warehouse, where transformations occur using the warehouse powerful processing capabilities. Modern tools like Snowflake or Google BigQuery leverage ELT for flexibility with large, unstructured datasets, enabling scalable analytics and faster insights. That's a wrap for part 2 of our Backend Concepts series, covering key topics from synchronous versus asynchronous to ETL versus ELT. Mastering these fundamental concepts builds your confidence and effectiveness as a full-stack developer, empowering you to tackle complex projects. If this video clarified these concepts for you, hit the like button and subscribe to stay updated with more content to fuel your dev journey. I'd love your input. What backend concepts should we dive into for part 3? Drop your suggestions in the comments below. Thanks for watching, and stay tuned for more insights to level up your full stack skills. See you in the next video.